This video will cover the topic, solving a system of linear equations using elimination with addition. Let's start off by quickly going over what exactly a system of equations is. A system of equations is a collection of two or more equations with the same set of unknowns. In solving a system of equations, we try to find values for each of the unknowns that will satisfy every equation in the system. Now, let's take a look at an example. In order to completely solve the system of equations, we will need to find a value for x and y that will effectively satisfy both equations given. One method that we can make use of to effectively solve this system of equations would be to eliminate one of the variables. So, we may solve for the solution of the second variable. To do this, we must remember that when looking at equations, we are allowed to combine like terms, meaning that in this system of equations, we were able to combine our x variable in our first function with our x variable in our second function. And the same thing goes for y's and constants. By looking at the initial equation, we can see that the coefficients on the x terms are the same. This means that we can eliminate the x variable by subtracting the second equation from the first equation, like so.
Wait, but don't we need to remember to distribute the negative sign throughout the equation 5x plus 8y equals 25?
Yes, you would be correct. When we do this, our system of equations now looks like this. Now that we've distributed our negative sign throughout our second equation, we can add the second equation to the first equation. Taking note that since we've distributed a negative sign, our 5x's now cancel out, and we are now left with negative 4y is equal to negative 20, which we can then simplify by dividing both sides by negative 4, and our y value is y is equal to 5. Now we can solve for x by substituting y is equal to 5 into one of the initial equations given in the original problem. Let's use the equation 5x plus 4y is equal to 5. We're going to start off by substituting 5 in for y. 4 multiplied by 5 is equal to 20. Now we are going to subtract 20 from each side. Resulting in 5x is equal to negative 15. Next, we will divide both sides by 5, which results in x is equal to negative 3. Thus, our final solution for this system of equations is y is equal to 5 and x is equal to negative 3.
Why did we decide to use the first equation from the system of equations to solve for x instead of the second equation?
Good question. Even though we chose to use the first equation from the system of equations given in our initial problem, either of the initial equations can be used to find the value of x. If you were to substitute the y value of 5 into the second equation, 5x plus 8y is equal to 25, you would get the same answer of negative 3 for x.
Okay, I think I get it. So the first step is to make sure that one of the variables in our system of equations has the same coefficient in both the first and second equation. If this is the case, we can eliminate this variable by either adding or subtracting the equations and then solving for the remaining variable. We can then substitute the variable we just solved for into one of the initial equations given in the problem to find the remaining variable. And our final solution is the corresponding value for each of the variables we solve for while completing the problem.
That's right. It really sounds like you understand the topic.